So in the first video I did, I introduced the concept of trigonometric ratio. If you have a look at the screen, I've got two triangles here. You'll notice both of them have an angle of 45 degrees. They're both right angle triangles. And when you do the ratio of the opposite to that 45 degree angle divided by the adjacent length next to that 45 degree angle, for the first triangle you get 5 divided by 5, which is 1. For the larger but similar triangle, so it's got the same internal angles, these are both isosceles triangles because they both have same lengths, they've got a pair of sides of the same length. So when you work out the opposite length, EF here, which is opposite to the angle 45 degrees, and the adjacent divided by the adjacent, which is adjacent to the angle 45 degrees, you get EF divided by DE, you get 10 divided by 10, which is 1. So you can see both triangles have the same ratio. Now in the first video we introduced, this has a name, this ratio, we call it the tangent ratio, or abbreviate it as tan. And you can check on your calculator what the tangent ratio is for 45 degrees. You type tan 45 and you get 1, which is what we're showing with our measurements of the triangles on the screen. And if you want to work out, well, what is the angle that corresponds to a ratio of a tan ratio of 1, well, we use the shift tan key, which gives us the inverse tan. Type the ratio and hit equals, and it gives 45, so which matches the angle you have on the screen. Okay, there's two other types of ratios, so I'll just go and find so firstly let's look at sine and just find the so sine is opposite over hypotenuse, and I'll just bring up the ratio. Yeah, that's correct. And for the other triangle, should be not that one, this one I think. And I'll turn on the lengths. Just give me a second to find. There it is. So the length of that one there's FD is 14 point something, and this one CA, right? So let's look at the sine. In fact, I might turn off the tan ones. So just pause for a second while I turn that off and I'll come back. Okay, back to the video. So now what I've done here is I've just hidden some stuff. So I'm going to introduce the next ratio. It's called the opposite over the hypotenuse. So what that means for this particular angle, the opposite side, again, opposite that angle will be this length here, 5. And the hypotenuse, of course, always the longest side in the triangle, the right angle triangle, in this case 7.07 something. So when you come to the ratio and you go 5 opposite divided by the hypotenuse 7.07 something for our first triangle, you get 0.7071. Let's look at our larger triangle. It's again the opposite side to the angle is 10 and the hypotenuse is 14.14 something. So when you do the ratio 10 divided by 14.14 something, you get 0.7071. So again, you see they're both the same ratios. Again, we can modify this and we get a different I think it might be about there it is. So again, you can see for a different angle, now we're at the angle 30.96, we've seen this one before. Opposite 3, hypotenuse is 5.8 something, you get about 0.51 something. The large triangle, opposite is 6, hypotenuse is about 11.66 something. So again, you divide those two numbers, that's the ratio, and you get 0.51 something. They're both the same triangles. Again, we've seen that before. They're similar triangles, different size but the same angles. So we call that the sine ratio. And again, let's go to our calculator and just confirm. So for this particular one, if we press sine, type in 30 point, type in the angle, your scientific calculator will give you the ratio. There you go, 0.514 something, which matches what we got on the board there. 0.5145. If you want to find the actual angle that corresponds to that ratio using the sine, hit the shift key, hit sine, so we bring up inverse sine, type in the ratio, hit equals, and you get 30.96, which matches what the actual angle is. So we're going to use this to find angles, this inverse sine or inverse tan. So that introduces the sine ratio. So in the next one, final video, I'll introduce the cosine ratio.